So hello everybody again. We are starting day 4 of the synthetic intelligence workshop. Good to see everybody. Let's see when everyone will connect. See that some more people are joining us. So today we continue working on your models, but we will go from the coding, from machine learning to the visual language encoding to Grasshopper and start working on the 3D modeling of your final models. But before we do so, I would propose to start with a very little review of your previous steps. It's just that I see that everyone done some point clouds, nobody had any problems, and also I would understand what are you doing exactly, so I could drive my class according to your progress. So for that, I will give you permission to share the screen, and I would ask maybe just for a few seconds to share your screen, show what you have, the video, the point clouds, and share with us at which step you are. Should this start with Anais?
Hi.
Hey.
So yeah, I made a few videos and tried a few different point clouds as well. I'll share my screen. Okay. So I kept working with the same images of satellite imagery of Arctic ice. I tried to select from the range of images that I generated. I tried to select a few that had decent contrast and structure to start with for the interpolation videos. So yeah, I can just show a few different ones.
Beautiful.
So this is one example, and then I also tried slightly different thing. That's a little bit slower. And then I think this is the last one or the first one. And then out of the few point clouds that I have, I think this is the most interesting looking one, because you can still read some kind of structure, I feel. So yeah, I think this is where I'm at right now.
Very nice. Okay, thank you very much. Nice. Delfina.
Sorry, I was muted. So I used some images of diatom structure and the ones here, some videos. At the beginning, they do change, but I wasn't getting much of a transformation, I think. So then I went and I did this one. This is an intermediate one. Do you hear me? Okay, sorry, I have people having a meeting.
That's okay.
And then there's a one that it's like eccentric, I think. Didn't quite much understand the evolution of it. We'll see and so then the point clouds are generated. Two of the options. I did also quite a few trying different patterns. This is both ones. This one is the one that is more like the last video, and this one's the intermediate one.
Very beautiful. Okay, thank you, Delfina. Gabriela.
Hi, I'm sorry, today I'm not in my computer, so I'm just listening, but I got my cloud point, and I think it works fine with the video that I make or show you the last
Okay.
class.
Okay, super.
Sorry, thanks.
Oh, that's okay. Julia.
Oh, hi. Let me share my screen. So for me, the point clouds worked quite well. I think you can see them. This is like 720, the biggest one. I don't know how to, and then this one, which has like spaces in it. It's basically bacterial cellulose. So it's been taken out of images from. Can you still see it?
Yeah, we do.
Basically, these are the images that I've made the frames out of. And I think it went out really nice, considering that most of my images were gray and blue, and it has quite like a nice color.
Very nice. Thank you, Julia. So then I have Feves.
Okay, I can go. Share my screen. I quite like the result a lot, and I try to generate a lot of video. And this is my point cloud. And my video, I collect a data set of galaxy, and I like this one the most. They have a lot of variation in it. It's look quite nice. And other video is it's just like don't have a lot of variation like that. I'll try to generate a long, very long video, and yeah, something like that. Okay. Really nice to look at it.
Okay.
Thank you.
Yeah, very beautiful. G.
Sharing.
Hello.
Hello, G.
I'm sharing now.
Yeah.
So I tried to make two geometries. The first one is something like this, with a desert landscape. And the other one is this one with, is like the south part of Chile. So it's more like an Arctic landscape. The problem is this one got this kind of lake or water hanging. So I couldn't make the point cloud with this one. So I made it with the desert one. I got this one. The problem is it don't keep the coloration because as you can see, it's kind of bluish, while the original video is pretty brown or orange. So I don't know. Yeah, I got this one. And also I got this area which is without point cloud. I don't know, maybe it's because I have some white parts, or I don't know. But I still like it.
Okay, we will see how to work with that. That's good.
Yeah.
Thank you. Danny?
Hi, can you hear me?
Yeah.
Okay. Okay, wait. Okay, can you see my screen?
It's starting.
Okay, I trained one network and the results were not good. Like you see in the chat. So I trained a second network, and this is the video. It's a little bit long. And with this video, I did this point cloud that is really colorful. I think it could be interesting for what we are going to do today. But yeah.
Yeah, super. Thank you, Danny. Yuxi?
Hello, I'm gonna share my screen now. Yeah, so I was having the video here. I still have the diatoms as the data set. So it was pretty much the outline, not really like so much information on the frames. So you can check the point clouds. Yeah. Do you have the Rhino here? Can you see that? The model?
No.
Oh. Do you have my screen now?
Yeah.
Okay. So as we can see for now, it's just like the outline of the algae, but I guess maybe you could work with that. And I'm also training another model, which is from the dataset you were providing, the high carbon images. So maybe there could be some kind of cube point cloud later. And I haven't produced any video from that yet. So I'm gonna having like two sets of model.
Yeah, I think it looks good. Thank you, Yuxi. Great. Shangyu?
Hi. Actually, I thought out a new idea, but there's something strange of my output, and I stopped in this step, sorry, and try to discuss with you today. This is my input image. They are the sections of the ant nest, because I think it's interesting that the ant nest always has some hierarchical relationship, and the workers and ants are usually closer to the soil surface, and the male ants are always in the middle, and the queen are always living in the deeper, and the society of the hierarchy of the ant nest is like similar to the hierarchy of some human relationship. So I would like to try to apply it in the hierarchy of the and from the frame to the 3D structure. It seems that it can become present of the some hierarchy of human relationship in final 3D, like the city or something. But however, the train doesn't look pretty good. Actually, this is the final train output. It looks a little bit overtrained. And we can look from the front, but it's still a little bit different from my real image. For example, you can see firstly, the distribution of the internal looks homogeneous. I don't think it's like strange, and the terminal are sometimes interrupt, like here, and sometimes the terminal looks white, and so I don't think it's a good result. So I want to discuss with you, how can I figure out? Maybe because of my input images, the number of it is not enough. What do you think?
Well, I think the outcome is not bad. Do you have a point cloud so we could see it?
No, actually, because I just I don't know. I stopped it because I think it's strange. Sorry.
Okay, so maybe we would need to check that a bit individually, how to advance with your
Okay.
point cloud generation and the video generation. We could check that separately. But for now, maybe I will share with you another point cloud that you could be working with, and you could just test an abstract point cloud from kind of my experiments, and then you catch up with your personal point cloud when we fix it.
Okay. But I think it's the 2D frame problem. If this 2D problem is not solved, is it okay in the point cloud?
Well, for now, we will be working with another point cloud since you don't have your, but we will fix it. No, so we will just connect after the class and check it separately.
Okay.
So super. Thank you very much, guys. I see that I still have some problems with my software, and that's why I was a bit late, and I still have the same issue with my Windows side.
Okay.
So to start, I would share with you again a folder that I've made for file exchange. So I'm sending it.
Maria,
Yeah?
I can get access to the folder.
You cannot.
Yeah, same for me.
Yeah, me neither.
Yeah.
Okay, so I blocked you. So, okay. Basically, the Google Drive folder looks like that. And you see here that we have, this is our folder. Let me check. Change. Yes. Anyone with the link is an editor. Okay. Copy. Done. Super. Sending again to you in WhatsApp. Sending again to you in here. Try to access it now.
Yeah, now it's okay.
Super. So do you have both folders here?
Yeah.
So you should have these two folders. For the submission folder, we will ask you to maybe start making the folder with your name and share with us some materials that you are doing. You could also share in this folder with us some ongoing materials for the questions if you want. But by the end of the workshop, we would like to prepare an exhibition of your work and publish it, so you'll be a bit promoted. And if you don't mind to share like your videos, maybe your PLY files would be also useful. So I see how to evolve each of them and the final result. So that would be great. And in the Grasshopper folder, you will find here few definitions. Please download them and maybe start opening them on your in your Grasshopper. Well, PY it's a Python file for Rhino, and Grasshopper files are for the Grasshopper. So you could open both of them and check if it's working now, and or if you need to install any plugins. So please do it now, and I will try to access meanwhile my parallel. Guys, girls, can I make one of you a host while you're installing to restart my computer? Who could be the responsible person who wants to stay till the end? Nice.
Yeah, I can do that, sure. Yeah.
So I just make you a host.
Mm-hmm.
You're now a host. So when I restart now, nothing will stop.
Okay.
Super. So I will be back while you're setting up the Grasshopper. I just restart my computer. I have some problems with the software. Sorry about that.
See you in a bit.
See you in a second. I'm back. Sorry for a little delay. Did you manage to open everything and access it?
Yeah, there are a few components or plugins missing when you try to open the Grasshopper files.
Okay, which ones?
Let me check again. I think one was Tarsier or something like this.
Tarsier, okay. So, but maybe we don't really need it. Skip it.
Okay.
We will install it if it will be needed. So Also, Shangyu, especially for you, I uploaded in the Grasshopper folder the file, Rhino file called point cloud GAN. Are you using Rhino 7, Rhino 6?
Rhino 6.
Okay, let me in this case export it for you in Rhino 6.
Oh, thanks.
That you could use it. It's just the one of the files that I was using before the generation. So it's very similar to others, but a bit lighter. So you won't have that many points, so it will be a bit easier for you to work with that. But I think that's good. And then you could continue with your own.
Oh, thanks.
So, but also feel free, of course, to experiment, or to continue experimenting with this one. Okay, so it's already in the folder. So maybe I will actually work with this one. Since we have it open, I will share with you the screen.
Maria?
Yes?
I have a question. Is the Visor Realm plugin necessary? Because I can get to work it on Grasshopper.
Which one?
Visor Realm. It's in the grid Grasshopper.
I think we are good. Let's see and let's check what we are doing. So I have shared with you two Grasshopper files, one called read, another called Voxel. So probably you are working with quite a heavy point clouds, and I'm not sure you really would handle to work with that directly. So that's why I was preparing for you some options, how we could basically work with this file, dividing it. Now, so this point cloud is very small that I have here. But in case I will open my another file, which actually was done with the same method as yours, you will see that our point clouds, this one, is much heavier than we want. Okay, we had someone who have never used Grasshopper before. Who is this person? Do we have today the person?
So, yes, it was me.
Okay, super. So just also maybe for giving a bit of the clue about the software, you know, the Rhino software, it's quite intuitive. Now it has all the navigation system here, the paneling. You can basically click and experiment yourself, seeing that there is different tools, you know, and everything is working with a system of coordinates that you can every time by, for example, making a line, start controlling the resolution from the very beginning, from the starting point, then going to the specific dimension of the line that you want to have. Now, for example, now it's 100, and drawing with the system of coordinate. This is why it's so useful for the architects to work with this file. So you also, we have here the command line. We also can check in which units we are working, and basically this allows us to start setting up a proper documents which could go to the fabrication, which could go to the printing. Now, I'm working in millimeters, and I do suggest that you select from this list millimeters. Just you press OK, and that's it. So Grasshopper is a plugin for Rhino, and if you just type in a command line Grasshopper, you select, you press enter, and then the Grasshopper list, the Grasshopper plugin pops up here. Grasshopper is the basically another functionality of Rhino which allows to work with visual programming, and as well with Grasshopper we have a different sets of the tools which we are installing, as I was asking. In order to install the plugins to Grasshopper who have never done that, now you go to the files, special folder, components folders, and you drag and drop installation files here in this folder. But check that some files, like some, for example, Firefly that I was sharing with you, you were on Firefly, we didn't work, but well, some other plugins, you would need to install it as always. You would install a different software if there's an exe file, like this basic installation file. So we will start working, and I hope that everything will be quite intuitive for you. So in order to start importing now your point cloud here, well, also important that we are keeping our file organized. Have a structure of the layers, and please keep working on the layers, because we are working with millions of points. And in case you would need at a certain moment to select something and you'll have just thousands of points to select, you will just get mad. So, and so I think I have a point cloud here. To import the point cloud now into the Rhino system, we would need to have PLY file that you prepared a few days back. Now, if you go to File, Import, and you select your PLY file, you press Open, it will just allocate it here. It will ask you, do you want to work in millimeters? You press OK, and basically your file is here. And you see that I'm working, actually, this is the model of my PhD, and it's absolutely heavy. And for example, if I would like to move it directly to Grasshopper, for me, my laptop won't handle it. So I could manipulate it slightly in Rhino, but I won't be capable to start working mathematically with that. In order to start manipulating the file in Rhino, I have prepared for you and shared with you some Python scripts for Rhino. So in order to go to the Python script, now you should go to the tools. Annoying bar. You should go to the tools, go to the Python script, go to the run, and here you have saved two types of the files. Now, it's basically, these are the codes, Python codes, which are basically the Rhino is working same kind of, it has the same inside, it has the same engine, now the coding. So, and this is another code which we are adding to the functionality of Rhino in order to work with the Python cloud, with the point cloud. And here are two different scripts. One of them, clip point cloud, is clipping a part of the kind of extracting a part of the point cloud, and inverted is so basically the first one is clipping the cutting out the part of the point cloud and let you work with that. So basically leaving it on the working space. And the second one, inverted, removing some morphology out of your point cloud and leaving you the rest. So just to show you how it works, now you would need to have a certain morphology not to shape a specific part of the point cloud, because, well, while we want to have it selected, because the full point cloud is heavy and we want to take a small part. If you just, for example, do a mesh box and start selecting a specific area, I will do it now absolutely random. No? So I have done a small mesh box. Sorry, here I could. So maybe I would like to have it a bit smaller. And let's see, I just want to have it a tiny box. So it's light for me to work with, and I want to explain to, for example, I want this here. And in order to select, so I want all the point clouds inside of this box. So I go to the tools, Python script run, I select the clip Python Cloud Pro, I open, and it asks me every time. Rhino is very communicative, and it's every time asking and talking to us. So it's asking, select point cloud. All right, here is my point cloud. I'm selecting it. Sorry, it was frozen for me. So I selected. Select closed surface, polysurface on mesh. I've made a mesh, I've selected it. Processing, please wait. Okay, we are waiting. That's fine. So here, so basically I can just delete this mesh. It trimmed me a small part of the point cloud that now I will be capable to work with. But of course, this system is quite random. I just put a random mesh in the center of nowhere, and well, it doesn't give me the design strategy, you know, because actually I have this large point cloud here, and I would like at a certain moment to process and work all the point cloud, but maybe step by step, if I cannot handle it all. So for that reason, I was proposing to you, okay, should we work with a grid? No? And basically, how can we work with a grid? We could work with a Voronoi mesh, Delaney mesh, or just a simple rectangular grid, which helps us to subdivide this point cloud. Yeah? So for example, what if I want to create, let's start with the Voronoi mesh, which will be selecting me a certain parts and kind of dividing this point cloud by the components. Let's say that we are preparing the components. Here, okay, let's maybe work with this point cloud that we have here. What is this? This one, So, in order to do so, I would first, if I want to create a Voronoi, I would need to understand the dimension of this point cloud. And if you can go, for example, to the front by typing distance, you can just measure the distance between endpoints of my point cloud on one side. So this number 1923 comes here in the first slider in the x coordinate of my rectangular. And if I want to go to another side, I basically do the same. I just measure the distance. I put this in the second slider, and I measure the height of my structure. And again, distance, the height, and I put it in the next slider. So by that, I have all the coordinates. So first I create, sorry, I will hide the point cloud. I create the rectangular. And then from this rectangular, I create a box with the height that I've just measured. So in this box, I want to populate with the points that later on will start to create me a Voronoi structure. For these steps, I'm using the Tarsier plugin. It's this plugin which is also working with point clouds. Anna, I told you to not install it because maybe you just don't use it. You use another one, and I will show you. Then, if you want to use it, you can install it and complete it as well. But basically, this component filling the box with the point clouds, it's just a very basic method. I could control the amount of points which are popping up here that you see, and also here I have a seed of the randomness, and it's starting to create the certain manipulations within the point cloud distribution. Then, so basically here I've created a point cloud within this box. So, and then I need to extract each point here. For that, I deconstruct the point cloud, and I take the points from here and building up the 3D Voronoi mesh. No? And to manipulate it, I could check the random seed. I could decrease amount of cells that I'm working with, and I could start imagining that my point cloud will be divided by that mesh, will be divided. I have it already saved somewhere here, I think. No, so potentially I could, by this type of meshes, I could be dividing my point cloud and working as with the components by constructing a larger system. And here is the last step, is mesh join, because this component, if you bake it, baking, right click and bake, now it will give you a different separated meshes of the cell, but we want to have baked like a cells, something like this, of the Voronoi, and we want to have it joined together. In order to do so, we basically here in Grasshopper, we join them together. So when we bake the system, let me make a new Voronoi 2. Let's call it like that. When we bake it here in the Voronoi 2, now I have all these meshes. Basically, you see that they are solid and joined together. So that's one of the options. Or you can use others. So I will hide this one. And I will hide this. Sorry, I didn't hide it. So, or we could, for example, think about the Delaney mesh. And you could do different steps, or you could do it quite, I showed you a more manual scenario where you have a point, you create first a grid on the floor with these parameters of the X, Y, and a cell. So you're just adapting it to your size of the of your grid. So then you take these points. It's important that you're flattening it, that you have a solid list that you could be working further on, and you move them up. So basically these points are doubled up. For that I'm using series and Z coordinate to extrapolate this point cloud, which is basically my points are laying in the corners of each of this grid. They are here and they are moved 7 times with a distance of 400 up. And I'm having this kind of grid, and these points then I'm rebuilding with Delaney mesh. And again, this mesh I can bake, and if I bake this mesh, I will have it already baked here. I will have this kind of, again, components that I could be working with, and I could imagine that these are my cells that I'm working and dividing them. Instead of that random mesh that I was creating here before, I could be creating a grid. Another option, just to introduce you also the Volvox. The Volvox has directly a system of the grid. So where you have the first starting point, just to let you know the point, you can, now I'm getting a 0, 0, 0 points. So it's just by default. If you have your model somewhere on a different place, you can just place the point, put here the point, and set this point parameter here, and then use this here. So that's also an option. I will delete it now because I don't need it. But basically, this component of the cloud grid is automatically creating you a grid that I was making manually before. And you have all the parameters. So this one is the size of the cell. So this basically the size between the different points. Here I have the steps in the X coordinate, Y coordinate, and Z coordinate. So basically, if I change them, my proportions of the grid will change. I'm using this proportion just because it pre-measured it to fit into my point cloud, now to this one. So, and I'm doing just the same. I'm taking the points from here, from this point cloud. I again deconstruct the point cloud, because point cloud is basically as an object. It's not the separate points itself. In order to get the points, I need to deconstruct it, and I do the same stuff. And this is just one option. You can, for example, take this grid and make the rectangular grid and divide this point cloud just by the squares, or with any other options. It's just up to you. Now, how do you divide it? How do you structure it? Or like, yeah, feel free to experiment. So basically, to as my final kind of result, I was extracting one cell, for example, like this one, and I was trimming my point cloud with this mesh. And if I do it, basically, if I want to create a system and I want to make, or for example, I want to make the Voronoi structure, Voronoi system, I would just be dividing my point cloud by the several steps and creating separate components, which will be stuck together. The final structure, of course, we would need to think about the joinery system. I don't see anybody because I have hidden the screens now. I just want to see maybe if everybody is here, everything is fine. Are you following? Is it fine for you with this kind of speed of explanation? Would you like me to focus more on each component, and or you kind of more familiar with Grasshopper and we can go quite quickly? Because these are the basics. I didn't want to stop with them. Well, it's actually, I'm not showing you something super advanced. How is it? Tell me.
I think it's great. I can see your image is way behind your audio. I don't know if everyone is happening that too, or is it something that's happening with me?
Yes, it also happened for me. Just like the video and the sound is not matching, right? Yes, lagging behind.
Yeah, we can follow up anyways. And just take a little more time to see it.
Oh, I'm sorry. I don't really understand what's happening with this Zoom, but I don't want really to stop maybe now. If it's still understandable, I hope that we could follow. But as the speed of explanation of Grasshopper, is it understandable? All good?
Yeah, it's great.
Super. Okay, so we just continue with this step. Thank you, guys. Okay, so basically, I don't know what is the size of your point cloud. And I don't know if you could be working, if you need to divide it or not. But I really like the main, like for example, if I will work with my point cloud, it will be too heavy, as I said. I won't be capable to work with that. For that, I could show you the next step of the modification of this point cloud, or by components, creating this component system, or just show you maybe a lighter version that some of you will be using. So I've shared with you a second file called Voxel. Now, we just skip all this installation of the files. It's not needed. So, and here I'm using this mechanism to this code. Just a second, I'll close here. Okay. So as I showed you, I've created this small cell. And with the same system that I showed you, I trimmed with this mesh a small part of this point cloud. So again, I took I went to the tools, Python, run, selected this one, open it, selected the point cloud, then selected the mesh that I have here now, press enter, and it trimmed me at this small component. So with this small component, I can be safely working and kind of just dragging it and assigning it to my next definition, setting a point cloud. Yeah. So you can do that, or if your file is not too heavy, you could be just trying and assigning to this point cloud component full point cloud. So I don't know the parameters that you have been working. So, but to show you the second option, I will open another point cloud that I have here, the one that I've just shared with you guys. I think I have it somewhere here. Okay, I will tangents, open this one. So that's kind of similar things that you have, but I just know that this one is not that heavy as I had before. So this point cloud would be basically enough, like not that heavy, so I could be working with that. So to start working with this point cloud, I propose, like we have opened this definition, I propose to disable this component. Now, so we don't run full definition just by mistake and don't crash our computers. No, you can even disable for the beginning the second component as well. So you just want to have this point cloud. Oh, sorry. You just want to have this point cloud. Set, right click, set one point cloud, select the point cloud that you have on your screen, press enter, and see if it's basically assigned it here. It did for me. So now I could be probably switching off this point cloud, hiding it now in Rhino, and I'm working now with this point cloud in Grasshopper. I think here maybe it's important that you start following, because let's see what is happening. I will wait for you a bit now, maybe because it's a bit too fast now. So are you following this step?
Yes, though my Rhino crashed, so I will have to reopen.
Okay, okay. So in case your Rhino crashed, we changed the size of your point cloud, and were you selecting for the point cloud generation every fifth or point or every point? What is the size of the point cloud itself? Yeah? If you can tell me this variables, I can tell you if it will basically handle it or not. Because Rhino just using 1/4 of the computer, so basically there are some limits in processing a high and a heavy point clouds. That's why we basically at certain moment now we're introducing directly the Python or coding, because it's easier and lighter to calculate the code rather than visual stuff in Grasshopper. So for example, here I have the point cloud which is 1000 by 1000 millimeters with the height to like 190 more or less now. So, and I have every fifth point selected for the generation of this point cloud. So you see, it's quite light and it's working. So check the previous model that I was showing you, I would not be able to open. So in case you would like to work with your model and it's too heavy, I would suggest you to maybe for this step just to select a part of your point cloud and work with a part of the point cloud with the way I have shown you before. But keep in mind that in this step, when we are working in this definition, if your Rhino is not kind of crashing while you are assigning it to Grasshopper, we also have an option here to select with this grid, select a part of your point cloud to work with. So basically what we are doing here, we are starting to set up okay. We are setting up a grid with a starting point. I don't know how it would be better for you to do it, but maybe we could just construct the point. Okay, so I have here my point cloud, but I don't want to work fully with the full point cloud again. I want to make it faster, you know, for the calculation. I want to select a part of that. So I have the point in my 0 coordinate, and I want to create a box which will be cutting a part of my point cloud. I'm giving a parameter of this box. So now it's 400 height, maybe I have 300 would be enough. And I have it 400 by 400. So basically it's kind of a smaller rather than my point cloud, as you see. So I will be selecting and working with this, maybe even 300 by 300 by 300 piece to show you the process. So, and this cloud engine is helping us to select this with this box to select a part of my point cloud to work with. So we could here now start activating and enabling the my definition. So what I'm doing here from my point cloud, again, I need to extract the points to work with. So I'm deconstructing the point cloud by the points. You see that here is this one component of the Volvox, and what is great that it's not only taking and decomposing the points, it's also decomposing the colors. So you could keep working with the colors as well. So these parts here are done just for visualizing your point cloud, just to help you to visualize and understand. If here is just a point, here I could start modifying the resolution of my representation of the point to make it more or less feasible. But we kind of don't really use it. So, and then I'm extracting here my points in order to work further with this point. If I activate the cloud component, I see that the cloud engine, I see that it extracts with this box from this point cloud, it extracts a part and let us continue working with that. And of course, this box could be moved and modified again with the grid. So if you're working step by step, you could be kind of creating a grid and going with through your point cloud with the coordinate system to keep it organized. So in case your point cloud is quite light and you don't need to subdivide it in different parts, you just avoid using this cloud engine and you're working directly with plugging these point clouds into the definition. So, but I'm working here. And what I'm doing as a next step, I am converting this point cloud into the voxels. Again, it's a very basic step, which is the basic component of the Volvox, which is called, you see here, colored voxel. And I'm capable to control the dimension of my voxel, so, and see how I would need to have it. But, well, you have I know that you have a bit of the different point clouds now because your point cloud generation is cooling some of the colors. But what we could do here, we could also start reading the color. So second. We could also start reading the color by the next step now that I introduce you here. So basically, I'm splitting the information that I'm extracting from this point cloud, and we remember when we decompose the point cloud. Now I'm taking the information about the color to the split RGB component and giving an average and basically a range of the color numbers. No? In order to start selecting a part of them, a certain part of this point cloud, and using one or another color. And processing them the same way, moving to the voxel generation. So with this step, the algorithm is cooling certain colors that I'm selecting in this range. You know, you could start controlling it with the sliders or controlling it as well here. And starting to design this pixelated point clouds. And in order to kind of smoothen them, rebuild and reconstruct the voxel, I use just a few steps of smoothing them with the Viewerbird components. And I'm sure that you are familiar with that you can be selecting the strength and rebuilding them with the triangular or squared grids, and basically giving the results that you might like. And you could be working with this style of the pixel. You could, by again, controlling the size of the pixel, seeing how it comes together. Well, now it's when it's too large or too small, it stops working because it's just blurring everything together. You could be working with a smoothed mesh now, or you could be keeping now the modification of this mesh if you wish so. And by each step, you're having a bit of the different steps and different iterations. So, for example, if you bake it, you could start observing them. And comparing and seeing how you could work this out. And here we are working with quite a small piece now, with a very low res. But in case we are going back to my other point cloud, let's just save this one here. I would like to go back my synthetic intelligence point cloud because that point cloud has much higher res. And if I just start do the same steps as I was showing you before, and selecting an area. Again, I'm doing it randomly, but remember that, well, we don't do it randomly. I'm just doing it to increase the speed of my work and show you the results, but think that it would be better to select the grid and start working with a specific grid. So if I select from this point cloud, one piece, and I start working with that. Now I plug it here. Again, I disable several steps of my algorithm. Here I'm avoiding this part because I basically don't need it. I've already selected a piece in Rhino and it's quite small, so I don't need to use this part. Sorry. Oops. Okay, it's a mistake. So I'm starting just to do the same steps using the second point cloud, and you see that the higher resolution of this point cloud will allow me to achieve a different results, which are much more precise and much more beautiful. So now I'm selecting these point clouds and converting them to the meshing. Let's see if I take a smaller voxels. I have a higher density of the points here, so the step that I'm working is smaller. Let's go to the 7. So I really like the results which are coming from here. Let me make another folder. So, and yeah, that's the result that I quite like, I think. It keeps the structure. It has a very high res. And I think it looks quite beautiful. And think that this is just a part of my larger point cloud that I'm working with. Ah, I don't have it here. Oh, okay. So that's the procedure that I propose you to do. Does it work for you? At which step you are?
Yes, it worked for me, but it really need to very precise. If you just not careful and tweak something, it's immediately crash.
Yeah, so I think you need to control the amount of points that you're working with. And every time when you are, for example, if you're working at the beginning and the first steps, for example, by changing and modifying the size of this box, try to disable this component so it doesn't recalculate the whole definition. No, so I think that, yeah, you really need to be precise. and see until which extent you could get and what would be the strategy for you for subdividing your point cloud with a grid and achieving, but maybe you don't read and don't calculate full point cloud. Maybe you're selecting a part of that and it will be quite enough for you. Maybe you're making a sectioning. So it's up to you. How do you want to manage in the next steps? Are you creating a volumetric structure which is, I don't know, 2 meters tall, or you're just working with a few components and you're making a catalog? So it's maybe think how you would approach it now in your specific terms. So maybe today we are more working on activating this algorithm and making it work, and that's clear how it works. And tomorrow we could see and check your drawings that you are setting up and do a short review, seeing how do we drive them forward and which meaning do they have.
Maria?
Yes?
I have a question. So I tried to work with my entire geometry in the Voxel Grasshopper file, right? But if I want to work with my entire geometry, do I need to apply the Clip Point Cloud Pro Python or?
No, this one.
No. Yeah.
In this case, no. In case you, for example, want to work fully with your point cloud, no, that you, for example, want to, which would be great, no, if you could handle that. So if you want to import a point cloud, just a few seconds. It depends on the kind of how heavy your point cloud. No, you just select this point cloud and you assign it here.
Right. So the Python code is just when I need to, or I want to slice it, right?
The Python code is only in case when, for example, now you will be monitoring my screen. Let's see if it will respond me. Now, because my point cloud is that heavy that I cannot actually plug it into Grasshopper.
Right.
In this case, I've shared with you an option how to modify it directly in Rhino first to be capable to work it. But maybe you just don't need it. I don't know. So you see, for me, it's stuck, not responding, and that's not going to happen because. But I understand that this point cloud is too heavy for the computer to process, and also. Sorry. If you see the performance of my computer, it's, well, Rhino is taking everything, but actually my computer is not that overloaded. So how heavy or how powerful is your computer is not always helping with Rhino, that I've noticed. I don't know, maybe you could give me also some feedback from your side, because Rhino is using a limited amount of power of your computer. So basically, you could have, I don't know, several cores on your computer, but it will be constantly using just one because it was made for one. So it's, for example, Rhino is not using full power of my computer, and to free up the computer won't help him to calculate this point cloud. So there are some limitations that we need to deal with. For that reason, kind of, I'm letting you subdivide your point clouds, make it lighter, and a bit less painful. But of course, ideally, we would calculate and redraw full structure and get a high-res point cloud. I stopped sharing for a second because I need to now close my Rhino file because it won't respond me. I know it. So should we work few, maybe 10, 15 minutes online, and you start setting up the drawing, and I will be doing it together with you, and we make a little competition and show the results at the end.
I just have a question about the grid definition, the first one. Yeah, I'm not sure I understood what was the difference, or what was the point of like these different type of subdivision systems. Like,
I was just thinking how you could instead of selecting one part, imagine that, for example, I'm doing this, I'm using this point cloud in order to start 3D printing it. And I need to process a large point cloud. And I'm not it's difficult to process fully the point cloud. So I'm thinking on the strategy, how can I divide it? But instead of just randomly dividing it, I'm proposing to use a mathematical grid. First, it could be grid 10 by 10 by 10 by 10, and then you are selecting pieces, and you basically process with Grasshopper full structure, but part by part. Or you could, for example, by proposing a system of Delaney mesh, Voronoi mesh, or any other options, you could start thinking about this point cloud as a structure and thinking, what if my structure is divided in the different components and I'm processing each component, and then you could be selecting, not making it manually, but subdividing this point cloud with a structural grid and choosing a part and starting to calculate it. So that's the aim. But again, it's just a possibility of working with that.
If we are processing the entire point cloud, does the different type of grid affect the final result or not? I'm not sure.
It will affect, because it will be kind of calculating like bit by bit. But so you will see that the final result will be different rather than from the rectangular grid. But it's more about this, like a strategical thinking and kind of letting you the possibility to design a system rather than just processing the point cloud. So think that you could be, imagine that we have a large scale printer and we are 3D printing larger structures. Now, we were, for example, recently, well, not recently, it has been quite a long time. We were working with Claudia Pasquera and Ecologic Studio in the project. I will share the screen with you for the Centre Pompidou. We were commissioned to do this project, which is a large 3D printed structure, and it's done from the recyclable plastics. And it hosts the algae inside. So basically, to print this structure, we were using a small printer called VASP. I share it also with you, VASP 3D printers. They are very cool guys, and they have different printers which are working in large scale, so they even doing this stuff. But since we were working in the lab, we were just taking not the largest printer, we were just taking, we have in the lab this one. We'll open it now. This printer, no? So, and we were dividing all the structure into the component system that you starting to see here. It's hexagonal, and printing and placing them together. So kind of this system I'm proposing to build also for you. So thinking on the strategy, how we could construct it. Now you see here, now they are quite visible here. And all this project is basically, let's say, this kind of breathable wall structure or the sculpture, which is hosting the biomaterial inside, which is filtrating the pollution and giving you the oxygen. So what if we starting to think about your kind of point clouds with this large structure for printing? How can we create the strategy? So that was the aim why I did introduce it. But of course you can say, look, I'm not dividing it by the components. I have it's calculating well. I don't have that amount of points, and I just calculate fully the structure and I see how do I approach it.
Okay, thanks.
Anybody else have a question? Okay, to see now working. Okay, 10,000, 1,500. I think it should work. If your point cloud's not that heavy, yeah, just let's try to work with that. So I propose to keep online and start setting up a work with this definition. And we are finishing at 6 today now. Or at what time we're finishing? At 5, sorry. Right? 2. No, we actually run out of time. We're finishing at 4. So sorry. So, but if you want to, like, we could close the session if you wish, or we could just check how it works. So I could let you work with that a bit, experiment, and we check it tomorrow. What do you prefer? Okay, keep working. In this case, I let you work this evening, and we meet again same time tomorrow to check what you have. If you will have any questions, we will resolve that. If you have any problems, drop me a message. If you have any questions now, please ask, and I will go through it again. Otherwise, yeah.
I have a question. At the Grasshopper script is bug crop. I wonder if there is a component that is we input our own geometry and then crop out the geometry. This part is a bug, right? But if we use our own generated model, like a sculpture or something, and then use the crop and then grab the point cloud, use the cloud engine to grab that geometry. Am I clear?
Yeah, if you have your geometry in Rhino as a mesh or as a surface, you could do it with a Python script. It will be easier.
Okay. Oh,
same as I was showing you how to crop it with,
okay.
With a square or with a triangle or with a Voronoi cell. Take your geometry and crop it with this.
So this Python script is only applied for mask or BREP or anything polysurface. Anything will work, right?
Polysurface, mesh, or closed surface, yes.
Okay. Thank you.
Mm-hmm.
That's really beautiful.
So far. Okay, I am really looking forward to see what you will have.
Hi, Maria.
Oh, sorry.
I have a question. I have followed your step just now. It looks good, but in my case, just now I show you the problem that my output is not so good. So do you know how can I figure? How can I?
Okay, share your screen.
Sorry. Here's my following your tutorial. It looks good, but it still is my problem of the
we don't see the Rhino. Are you showing the Rhino or?
Yeah, I showed.
Yes, now we see. Okay,
yeah,
it's perfectly working. It's just the low res image. That's why it's not good. It's just few point clouds, like a few points in the point cloud that you have. So in your case, I would suggest you to proceed with the point cloud generation from your style gun.
Yeah, it's the problem of my style gun. The output is not good. So
yeah, let's chat in WhatsApp, and I will write now to Artem, and we maybe check with Artem together the problem here. But
okay.
I honestly think that the results are quite good. I don't.
Really?
We need to see what is kind of, well, it depends what you want to achieve. I think the process runs, no, and if you just follow the steps, you will have like a point cloud that you can be working with. Maybe your problem is that you are kind of that you want to control the grid more, no, and I think you need to stop training a bit earlier or take the frames for the point cloud generations, which are not the latest ones, but before. So you remember now that at certain moment, it starts to lose the structure of the pattern that you are working with. And if you want to keep the pattern, maybe you don't like train it till the end, let's say, but stop in a certain moment and work with those images. So I think this is just the way how we should work. But in any case, let's also check it with Artyom. Maybe there are some technical things that he could help you to do, and we will write you now.
Okay, thank you.
But basically with the Rhino, I think all is good. Just if when you will have your point cloud, you could be working a much higher resolution.
Okay, thanks.
Right, Delfina, you also had a question.
Yes, hello. No, I was going up through the Grasshopper and just wanted to check the parameters that we are going to use. Is it only the voxel size? I mean, first the grid, you know, which part to cut out of the point cloud. But then in the voxel Grasshopper, is it only the voxel size we've got to
the voxel
use?
size, the strength of the mesh generation for the view the bird, the color selection, if you wish, you could also be modifying the color. And also by selecting the area that you want to kind of work with, you could also tweaking the results. And but of course, this just one of the options to work with that. And you could experiment a bit more and feel free to add your thoughts. Maybe you could post-process the voxels differently. We could also think how we could go from the voxelization to some maybe interconnection of the points within the grid. For example, when I was showing you first class, my presentation of the PhD, I was also using these points to interconnect them just with the lines, designing the path for the printer. So that also could be, feel free to experiment. Within this algorithm, I think, yes, there is like 3 parameters, well, 4 parameters. The area to work with, the voxel itself, the color that you're working with, and different strengths of the meshing in the view the bird. And you, or you could, for example, some people also just working with the voxel itself and making this more pixelated, mesh, and think that it's also you could extract the wireframe of the voxel, and you will have this kind of line drawing which could be meshed into the pipe, and then you will have this hollow structure, which is also very beautiful and could be approached differently. Super. The rest, all good. Yuxi, Julia, G, Gabriela.
I just have one question. So the idea of the final outputs is to get this kind of like catalog of this kind of, or what? So what we should like go through, or what's our main goal?
Yeah, that's actually a good question. So I think that we would need to catalog the experiments, and for the final presentation, well, we already have the video, then we could catalog all our steps or our different iterations that we are doing. And I would propose to set up a final drawing, a render or the drawing of the mesh that you have. And what is important, I think, is to keep through your presentation this visual language. When your style gun video and the first data set, then the style gun, then the point cloud and the final outcome are starting to create a visual language. And that's, I think, the most important. And tomorrow we will talk more about that. When we see your results, we will think how to set up a drawing for you. And are you working with renderings or some drawings? For sure, all of you. I saw your beautiful portfolios. I think I could go to your workshops to learn some renderings and drawings rather than teach you to do that. So I think that all of you have a bit of a different style, and maybe it's also a great thing to experiment that we have different varieties of the drawings, no, and the styles of the drawings, but all of you keeping the visual language that of your presentation, of your personal presentation. So if you want to, for example, now when you're starting to work on that, you can already start collecting it in a short presentation, just dragging the images in the like slide. I would suggest you, for setting up the presentation, to try keeping it clean, trying to avoid large amount of text in the presentation, keeping the just index of information that you are using. Don't overwhelm one slide with a lot of images. If it's a catalog, then there is a coherent catalog. I was presenting you some of the catalogs in the first class as well. If it's a drawing or render, keep it full screen and keep it clean. So this may be my suggestions, how I would set up the final outcome.
Okay, thank you.
Great.
So Maria, I
Yes.
have another question about the style GAN generation. While I watch your presentation about that Voxel, I see there are a lot of variation between the interpolate loop. But while I try to generate, don't have a lot of variation. I wonder if you generate a very long video and then condense it to short, and then or you just have a specific parameter to play with? Because I try a lot, but still not a very good result.
I think it's all depends on the data set. So if your data set has some kind of specific varieties, then it starts reading it, no? And this kind of patterns of the wood, it's very kind of sharp, very like it has its own characteristics, and I think that's how it works. And you can perceive it in the video generated. And then we were not we were not running it too long to keep the structure. And we were selecting, I think, every fifth layer to generate the point cloud, and that's the result. But it's very much, depends on the data set that you're working with.
Okay, cool. Thank you.
Actually, the image that I have at the back, it's also one of these kind of works that we were doing, but this is a landscape. So it's also kind of, but you see, it's also more blurred.
Quite amazed, really beautiful, and yes, it really fit my aesthetic. It's really beautiful.
Thank you.
Thank you.
Thank you so much. I'm super happy to work with you. It's Artyom as well. We were talking that it's a great pleasure sharing what we are doing and getting some feedback from you and seeing how do you approach it. It's a really, really great pleasure, and I'm really amazed by the team that we have for the workshop. So I'm looking forward to see you tomorrow, and also sharing your work with on the final reviews. So I think that kind of the main part of the kind of tools, instruments, the knowledge that we wanted to give you, we kind of gave. I put specifically one day more just to double check and have a bit of a more discussion tomorrow, that we are kind of ready for the finals and we maybe have a chance to talk through each work. But the main part is here. Don't expect tomorrow a large definition, which you would again need to handle, only if you wish so. knock and I will think something else. What can I share? Yeah, so I won't take you more time. I know I took 50 minutes more, and also because of my problems with the computer, just my parallel couldn't open on time. And yeah, have a lovely evening or day, morning, whatever country you are, and whatever weather you have. I see that Delfina is in the cold. And is it cold? You're in Argentina, right?
Yes, I'm in Argentina. It's quite cold right now. It's in the morning. Yeah.
Wow, impressive. I'm in the north. I'm in St. Petersburg in Russia. It's kind of closer to North Pole and Finland, and it's supposed to be very cold here. But now we have white nights and it's like 30 degrees, and we are quite surprised that it's so warm here. So yeah, and it's 5 o'clock here. Wow, Danny is always in the Summerland. That's a lucky people. Great. So have a great day, have a great morning, evening, night, and we see you tomorrow.
You too.
You too.
Thank you.
Thank you so much.
Yeah,
Thank you very much.
Bye-bye.
Bye-bye.
Nice. I will ask you just to stop maybe streaming. I think it's easier that you just need to